Imagine a world where computers can think and learn like humans, where they can help us solve some of the biggest challenges facing our planet, like climate change and disease. This is the world of artificial intelligence, or AI. AI is already being used to do amazing things, like driving self-driving cars and translating languages. But AI is still in its early stages of development. To reach its full potential, AI needs a lot of energy. That's where Microsoft's controversial plan comes in. Microsoft wants to power AI with nuclear reactors. This involves using small modular reactors, or SMRs, which are essentially mini nuclear plants. Nuclear reactors are a powerful source of energy. They can generate electricity without producing greenhouse gases. This makes them a low-carbon source of energy. But nuclear power is also controversial. Some people are concerned about the safety of nuclear reactors and the risk of nuclear accidents. In this video, we'll explore Microsoft's plan in detail. We'll discuss the benefits and risks of using nuclear power to power AI, and we'll leave you with something to think about. Is Microsoft's plan a good idea? First, let's talk about why Microsoft wants to pursue this in the first place. In short, it comes down to the massive energy demands required for advanced AI systems. As Microsoft expands its cloud computing capabilities and develops more sophisticated AI-like large language models, it needs way more power. We're talking about mind-boggling amounts of computing power required for AI training and running complex neural networks. This puts huge demands on energy grids, which currently rely heavily on fossil fuels like coal and natural gas. Some estimate that training a large language model, like GPT-3, results in emissions equivalent to 125 round-trip flights between New York and San Francisco. So if the broad proliferation of powerful systems like GPT-3 continues, energy usage will go through the roof. Microsoft is hoping nuclear can provide abundant, low-emission power to prevent AI progress from stalling out due to energy constraints. Microsoft wants to reduce its carbon footprint too. Nuclear power does not directly emit greenhouse gases like fossil fuels do. There are still emissions involved in things like mining uranium, but overall, nuclear has been shown to produce far less emissions compared to coal or gas plants. Furthermore, nuclear power provides steady, reliable baseload energy production compared to renewables like solar or wind, which fluctuate based on weather conditions. For powering data centers 24/7, Microsoft likes that aspect of nuclear. So this move could allow Microsoft to expand its AI capabilities while also achieving its sustainability goals. However, some critics are skeptical of Microsoft's true motives here. They point out that Bill Gates, Microsoft's former CEO, is a major investor in a nuclear power company called TerraPower. Gates has been promoting nuclear as a solution to climate change for years, so some see this recent push as mostly serving business interests rather than purely for environmental reasons. In the meantime, let's get into what exactly small modular reactors are and how they differ from conventional nuclear plants. Most nuclear power today comes from large, water-cooled reactors located in a single large building. They benefit from economies of scale. The bigger the reactor, the cheaper the power. But SMRs turn this idea on its head. As the name suggests, SMRs are smaller, typically producing 100 megawatts of power or less. That's about 1/30th the size of a typical reactor. SMRs are largely built off-site, in a factory, leveraging modular construction techniques. This makes them faster and cheaper to build. Their small size also allows for different cooling methods beyond water, like liquid sodium or molten salt. The modular parts can then be transported and assembled on site at a power plant. So in theory, SMRs provide several advantages: smaller upfront capital costs, faster construction times, enhanced safety features, and the flexibility to scale power production up as needed. So how does Microsoft intend to actually implement this SMR strategy? Well, in September 2022, Microsoft posted a job listing for a principal program manager for nuclear energy technologies. Based on the details, this person will be responsible for developing an overall roadmap to integrate SMRs into Microsoft's energy supply, as well as choosing technology vendors and partners to work with. The end goal is for Microsoft to gain a completely domestic US supply chain for nuclear power. This includes fuel procurement, since currently, America imports a lot of its uranium and enrichment services from places like Russia. Through partnerships with American nuclear companies and fuel services providers, Microsoft hopes it can create a nuclear ecosystem solely in the US. The job listing specifically mentions that the role will work with engineering teams on the technical design and viability of SMRs. Beyond just powering data centers, Microsoft seems interested in SMRs for its overall operations. The listing mentions implementing SMRs across all of Microsoft's facilities, so the company clearly sees an opportunity here to lead the charge in adopting this new nuclear technology. Given Microsoft's massive resources and influence, it could very well drive more widespread usage of SMRs going forward. But Microsoft's nuclear ambitions have not gone without criticism. Nuclear power tends to be a highly polarizing form of energy production, given concerns around safety, waste, and weapons proliferation. Major incidents like Chernobyl, 3 Mile Island, and Fukushima left lasting scars in terms of public perception of the dangers of nuclear radiation. This has slowed the growth of nuclear for decades now. The Chernobyl disaster in 1986 was the worst nuclear accident in history. It occurred when a reactor at the Chernobyl nuclear power plant in Ukraine exploded, releasing a massive amount of radioactive material into the environment. The accident killed over 30 people immediately, and thousands more have died since then from radiation-related illnesses. The 3 Mile Island accident in 1979 was a partial meltdown of one of the reactors at the 3 Mile Island nuclear generating station in Pennsylvania. The accident did not release any significant amount of radiation into the environment, but it caused widespread fear and distrust of nuclear power. The Fukushima Daiichi nuclear disaster in 2011 was a series of accidents that occurred at the Fukushima Daiichi nuclear power plant in Japan, following a magnitude 9.0 earthquake and tsunami. The accidents led to the release of radioactive material into the environment and the evacuation of hundreds of thousands of people. Another major concern about nuclear power is the production of nuclear waste. Nuclear waste is the radioactive material that is left over after nuclear fission. Nuclear waste must be carefully managed and disposed of to prevent it from harming people and the environment. Currently, most nuclear waste in the United States is stored on-site at nuclear power plants. This is seen as a precarious solution, as it poses a risk of accidental releases in the event of an earthquake or other natural disaster. The United States has not yet developed a permanent solution for the disposal of nuclear waste. Some people are also concerned that the development of more nuclear reactors, even smaller ones, could increase the risk of nuclear proliferation. Nuclear proliferation is the spread of nuclear weapons and materials to more countries. Some non-proliferation experts are uneasy about Microsoft's push for nuclear power, as they believe it could send a message to other countries that nuclear power is acceptable, even in the absence of strong safeguards against proliferation. On the flip side, advocates argue that nuclear power is far safer and cleaner than many perceive today. They say new generation designs are extremely stable, and accidents like Fukushima are unlikely to occur, and that fears around weapons proliferation are overblown, given stringent controls in countries like the US. Now let's talk about how Microsoft's nuclear ambitions could specifically influence AI development going forward. Clearly, Microsoft sees SMRs as having the potential to unlock the next wave of AI capabilities, which will demand enormous computational power. By tapping into nuclear, Microsoft can expand its data center capacity exponentially, training models with billions more parameters on countless more processors. This abundant computational power will remove energy constraints, allowing researchers to experiment with radically larger architectures and achieve new breakthroughs in natural language processing, computer vision, robotics, and beyond. In the near term, we may see novel generative models that are orders of magnitude more capable than today's systems like DAL-E2 and GPT-3. While concerns remain around nuclear proliferation and waste, Microsoft's move highlights how new energy sources will provide the fuel for the coming wave of AI progress. Critics counter that we should be careful not to progress AI too far or too fast without proper safeguards in place. There are concerns about AI ethics, bias, and societal impacts. Rushing ahead with advanced systems just because the energy is there could be dangerous in the eyes of some researchers. But others, believe radical AI progress is necessary to tackle challenges like climate change. Clearly, there are reasonable arguments on both sides, but Microsoft's plan could certainly accelerate the pace of AI innovation in the years ahead, if implemented as envisioned. This is a complex issue with a lot of technical and ethical nuances to grapple with. What do you all think? Is this a reasonable path forward to provide immense computing power while reducing emissions from AI, or an irresponsible endeavor given the risks and unknowns involved with nuclear technology? The decision of whether or not to support Microsoft's plan to power AI with nuclear reactors is a complex one. There are significant risks to consider, but there are also potential benefits. It is important to weigh the pros and cons carefully before making a decision.